Let's take a look at this problem. We got f of x is equal to 3x minus 1 over x plus 3. And first thing we want to do is find a domain. But whenever you have a rational function is a single fraction with x's in the denominator. Whenever you have a rational function, then you're going to set your denominator equal to 0 and solve it. So we got x plus 3 is equal to 0. Take the 3 over, and we get x is equal to negative 3. Now this is the answer we cannot have. If I put negative 3 in for x, I get negative 3 plus 3, or 0 in the denominator. So x cannot equal to negative 3. Now b, find the x-intercept. Well, for your x-intercepts, you always plug 0 into the other variable for the intercepts. So for finding the x-intercept, we'll plug 0 in for y. So we got 0 is equal to 3x minus 1 over x plus 3. Whenever you're solving and you got a single fraction equal to 0, you can set the top part equal to 0. So we're going to have 3x minus 1 equal to 0. Take negative 1 over, it becomes a positive 1. So we got 1 is equal to 3x. Divide both sides by 3. And you get x equals 1/3. And that's our x-intercept. Now C. C is to find our y-intercept. You always plug 0 into the other variable, so we're going to plug 0 in for x. Remember, f of x is the same as y. Y is equal to 3 times 0 minus 1 over 0 plus 3. These drop away, 3 times 0, so then we've got negative 1 over 3. So y is equal to negative 1/3 is our y-intercept. D, what is D? Vertical asymptote. Now for our vertical asymptote, we factor the top, factor the bottom, can't do anything there. We cancel if possible, can't do anything there. Then we set the denominator equal to 0. So I'll set x plus 3 equal to 0. And that gives us x equals negative 3. Reason why the graph doesn't exist at negative 3 is because there's a vertical asymptote there. Now E, horizontal asymptote. Take a look at your degree of the top and degree of the bottom. 3x minus 1, degree of that is 1. X plus 3, the degree of that is 1. When the degrees are the same, what you do is you take the numbers off the front of the x to the largest power. Well, there's a 3 in front of this x. And down here, there's an invisible 1 before this x. So we got y is equal to 3 over 1, or y is equal to 3. Now our slant asymptote. In order to have a slant asymptote, your degree of the top must be exactly 1 larger than the bottom. They're not. These are the same. So there's no slant asymptote. G, was that increasing? Yeah. Well, we got f of x is equal to 3x minus 1 over x plus 3. In order to find the increasing, decreasing, we have to find derivative. And this is a quotient rule. Top part will be p, bottom part will be q. We need p prime. The derivative of 3x minus 1 is 3. We need q prime. The derivative of x plus 3 is 1. Our formula for the quotient rule is p prime q minus p q prime all over q squared. P prime was 3 times q, which is x plus 3, minus p, which is 3x minus 1, times q prime, which is 1. And q squared would be x plus 3 squared. I was just double checking myself here. It's kind of early. Okay, so we did 3 times that, and that. Okay. Now get rid of the parentheses. 3 times x is 3x. 3 times 3 is 9. Now remember, a negative on front flips the sign of everything inside. So that gives us minus 3x plus 1 over x plus 3 squared. 3x minus 3x drops away. 9 plus 1 is 10 over x plus 3 squared. Okay, now we're ready to find our critical values. We'll set top part equal to 0, and we'll set the bottom part equal to 0. Whenever you have a rational, that's how you find your critical values. Now 10 equal to 0. There's no variable to solve for there, so I'll drop that one away. Remember, whenever you have a parentheses to a power equal to 0, then you can set whatever's inside your parentheses equal to 0. So this becomes x plus 3 is equal to 0, which gives us x equals negative 3. We want to build a table of intervals. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases. I want to choose something between negative infinity and negative 3, like negative 4. I want to choose something from between negative 3 and positive infinity, like 0. Now we want to plug those into our derivative and determine our sign. This one is super easy. We don't have to do any work at all. 10 is positive. X plus 3 to the second power, whenever you square something, it's always positive. Positive over positive is positive. So this is increasing here, increasing here. So this is increasing from negative infinity to negative 3. And it's increasing from negative 3 to positive infinity. H, min and max. Your min and max occurs where your graph changes from increasing to decreasing or vice versa. This doesn't change at all. It's increasing, increasing. So there are none. There's no mins and maxes. Well, now we're ready to graph it. Let's see what we said. Should label these, I guess. This is our vertical asymptote. Vertical asymptote at negative 3. It said we had a horizontal asymptote at 3. Like that. Our X-Intercept was 1/3. 1/3. That'd be right here. And our Y-intercept was negative 1/3. That should be right there. Okay. Now we're ready to sketch it. It's increasing, increasing. Well, if I drew it down here, it'd be decreasing. Not to mention that, but it would also have to cross the x-axis. We don't have an x-intercept over here. So increasing means the graph is up here. So it's increasing like that. Then it's also increasing, which makes sense since it crosses here and here. If it was up here, it'd be decreasing, and y-intercept would be up here. So it crosses there, so it has to go like that. Skimming those. Remember, that's what the definition of asymptote is. And eventually that'll skim that too. So more or less, that's what our graph's going to look like. I could plot points to see get this a little bit more precise, but that's probably good enough. Now, if I were to graph this on the TA3, TA4, the key is put parentheses on top, parentheses on the bottom. So let's go ahead and graph this on the calculator, see what it looks like. So press Y equals, press clear, do a beginning parentheses, 3x minus 1. Close parentheses divided by beginning parentheses x plus 3. Close parentheses. And then graph. A little bit better picture of what I came up with. But see, they're fairly close. Yeah, I guess that is about the right place. Anyway, those are our answers.